Hi, welcome to Math to the Power of Science. Today we'll be talking about stars. If you look up at the night sky, you can see thousands of stars, but that doesn't tell you what a star is. A star is born in a nebula, a cloud of gas consisting mostly of hydrogen, helium, and other elements. If one area has more gas than another area, it will draw the gas in, creating more density. Once it reaches a high enough density, it starts fusion. Fusion is when two or more atoms smash into each other, creating a new atom. This new atom is less massive, therefore has less energy than the previous one, so the lost energy is released as light. Fusion of the star takes place as hydrogen converts to helium, helium into carbon and oxygen into silicon, magnesium, neon, and sodium, and then those convert into heavy metals. Fusion is dependent on the temperature of the core, which is dependent on the density. If there is a small enough chance that fusion will occur, even though it's not hot enough that it should occur, and there is enough hydrogen atoms, then there is a good chance that it will occur. This is because small objects obey quantum mechanics, which I will talk more about in a future video. A star's core has to reach equilibrium. The gravity pressing in has to match the force of fusion going out. If fusion occurs too much, then the core will expand, decreasing fusion rates because of lower temperatures. This causes gravity to win, which heats up the core, and then produces more fusion, and the process repeats over and over again. Our star is not the only type of star seen in the galaxy. There can be supermassive stars or small stars. Scientists have come up with star classes called OBA FGKM. There are trends that follow these pattern, with B and O being supermassive, very bright, having lots of fuel, being bluer. The KM side sees stars that are smaller, have less fuel, dimmer, and redder. The crazy thing about stars is that the more fuel they have, the shorter they live. This is because of the star's equilibrium. With more fuel, it has more gravitational pressure. This means that it has to have more fusion going on. So even a big star has to have more fuel to go through. It goes through it really fast, unlike a small star, which has a little fuel but goes through it very slowly. This means that some of the smallest stars can live for 12 trillion years, while the biggest stars can only live for a couple million of years. What happens when a star loses all of its fuel, though? How does it die? Well, I guess you have to watch the other video I made on stars. The link to the video will be in the description, along with all the other links to the videos I mentioned. Thanks for watching. Leave a comment down below or suggest a topic for a future video. If you like what you saw, please subscribe.